Hey robot makers, hope you're having a good day so far. So do you want to make a paranormal ghost box using a Raspberry Pi Pico and a Pimoroni Display Pack 2? Then this is the show for you. Let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our keynote. So yes, all about making a ghost box today. Before I do that, I just want to share something that's really cool with you. So these are some of the prints from around the community. You might see your own name on there. These are the spooky, scary skeletons that I made last week, and people have been going crazy for these, printing them out. So you can see Pierre's got one there. He's printed it in a glow-in-the-dark effect filament, which is really, really cool. He said he forgets when he leaves it plugged in and it goes off in the middle of the night. That's really, really creepy. Daniel has got one there as well, and you can also see one of them from Jimmy Z. He's having loads of fun with this with the kids as well. So I've got mine just behind me here. If I just go in front of it, it'll set off there. We've got the pumpkin version as well. So I'm thinking about making some further ones of those different varieties. I think a witch one, a Frankenstein one, a little ghost one as well. Cool. So yes, session goals for today. We're going to make a ghost box using a Raspberry Pi Pico and some Micropython code, using some 3D printed parts and some other bits and bobs we'll go over as well. And we will also have a play with it too. So let's get to this. So what is this? What is a spirit box? So it depends if you believe in paranormal or not. Really interested to know, do you believe in ghosts and the paranormal? Leave a comment below, let me know what you think about that. So allegedly, these enable spirits from the netherworld to communicate with us here in the real world. And the way these things actually work, if you've ever watched like one of these ghost watch shows where they go into a sort of haunted location, they pull out one of these little boxes and it'll make sort of really staccato sounds that go like and it's jumping frequencies, and depending which frequency it lands on, there might be some audio playing on that, so you'll hear like a little snippet of sound, and you might hear words come through. So the idea there is that these random words it's just jumping randomly between different frequencies, the spirits could influence this and choose which words are being spoken and therefore make their intentions understood. So there's quite a few of these different spirit boxes out there, and I thought let's have a play at making one of them and we can learn some things as well about random stuff. So what's our ghost box going to do? So what it's going to do is it's going to choose some random, that's that really weird, it's going to choose some random words from a list that we define in advance, and it's going to display those words randomly on the screen. So it's just going to pick a random word, display it for a random amount of time as well. And if there's any spooky spirits out there, they can influence which words are chosen and how long they're sort of displayed for and when they're displayed. So as you're moving around the room with your little ghost box, it can then pick which word's going to display on the screen. So that means we need to do a couple of things to do with random numbers and so on. So how random is random? It's one of these little rabbit holes you can go down. So if you think about computers for a second, you've got your little Raspberry Pi computer microcontroller. If this is like a Pico, like the original one that doesn't have Wi-Fi on it, how does it generate a random number that's different each time if it's the starting point is always the same? So how does it programmatically generate a number that's unique? So there's quite a bit of interesting math behind this. So the way that this works in MicroPython and also Python, it uses something called the Mersenne twister or Mersenne twister. I tried to make sure I get the pronunciation of these correct. So Mersenne twister is a general purpose pseudo random number generator, and it was developed quite recently, 1997, by these two gentlemen. I'm going to try and pronounce the names. So it's Matsumoto and Takuji Nishimaru. I hope I got those somewhere like right. So the name derives from the fact that it uses the period length is chosen to be a Mersenne prime, 32 bits long. So what are Mersenne primes? So prime numbers we know are numbers which are only divisible by like 1 and themselves, like 1, 3, 5, 7, not 9, 11, 13, 17, 19, I think, and then it goes to 23, I think. So there's quite a few prime numbers. Mersenne prime numbers are similar, but they're usually to the power of 2 minus 1. So we have things like 137, 31, 127. So there's it isn't known if there is an infinite number of the same prime numbers or whether it's a finite number of them. Now, given that numbers are infinite, you would assume that these would be infinite too, but it's never been proven, so it's one of those mathematical curiosities. And when we talk about random numbers and pseudo-random numbers, if you think about like a lottery, for example, like the National Lottery in the UK, or any kind of lottery that's run by like a government, for example, how do they generate random numbers that are truly statistically random? So if a random number would be, if you had a dice and you rolled it, the numbers that come up there, if you plotted them on a little chart, the graph would actually be flat over time. So the same numbers would come up about the same amount of time over, say, like a million throws. Whereas if it was pseudo-random, you might notice that there is a slightly different variance to that. So in regular true random numbers, you'll get sequences of numbers. So you might get like 1, 2, 3 appearing in a sequence. You might get the same number like 3, 3, 3, 3 occurring in different roles. Whereas with pseudo-random, you don't tend to get that as much, and it's a way that you can actually see if something's truly random or pseudo-random if you're looking at this as like a data expert and you're trying to figure out, is there some encrypted code on here, or is it truly just random data? So that's one of the ways that you can sort of infer that. So random numbers on computers, microcontrollers, they use this in CPython anyway, Micropython, they use this Mersenne twister, and it actually means that you need to have a seed to start the sequence off, but you always get the same sequence. So it's something you can actually rely upon to always be the same if you wanted it to be, but you can change the seed, and we're going to have a play with that in a minute to have a look at that. And the way that they make random numbers kind of pseudo-random on microcontrollers is as soon as you plug power in, the microcontroller starts in the background a little count. That count is going up. So we can read that as being the time. If we have a Pico-based microcontroller that's got Wi-Fi on board, it can actually go off to the internet, get real time. If it hasn't got the Wi-Fi on board and it's just a regular one, whenever the power is applied, it'll just count how many seconds or microseconds have elapsed since that power is enabled. And then that current time is used as the seed when you first generate a random number. So that's a way that it can add a bit more randomness to it. So in the UK, there was one of the very first random number generators that we had for premium bonds, which was like national savings and premium bonds. So the idea being you can buy government-backed bonds, stocks and bonds, you can buy these bonds, and you also enter by buying one of these a prize draw, and each month a random number is chosen, and if you happen to be one of the people that has that random number assigned to your ticket, then you win whatever the prize draw is for that particular month. And it's gone through about 5 iterations. So this is called Ernie. It got the name from one of the engineers who worked on this. And this replica is actually at the National Museum of Computing in Bletchley, right next to Bletchley Park. So this Ernie 4, we're actually on Ernie 5 now. That uses quantum computing stuff to generate random numbers. But Ernie 4 used thermal noise in transistors as its source of randomness. Now there is one on the internet that uses I think it's like a plasma lamp, one of those lava lamps, and the shapes of them to generate random numbers. This one used just random sort of variances in the thermal noise from the transistors. So that's an input, so that it's not programmatically defined, it's not deterministically defined by the algorithm. So you can see there the second point. In contrast, pseudo-random numbers, although sometimes seem to refer to as random, are produced deterministically by a algorithm used to generate them, which means if you run the same program from the same starting point, you'll always get the same results. So it's not truly random, even though the sequence will appear random. So Ernie was the independent tested each month by the Government Actuaries Department, and they would only say that the draw has been valid if they can prove that it's statistically consistent with randomness. So they had quite a high standard there. And yeah, I visited this one and saw this one at the National Museum of Computing. It looks like 2 great big eyes, and the little dials go around as it's generating random numbers. So that's a little rabbit hole that you can go down to do with random numbers. Let's have a play with those. So what I'm going to do, I'm just going to go back to me for a second and just bring up Thonny. And I've actually had some problems this week with my serial port, my USB port on this laptop. So I'm actually just going to run, you can see at the bottom there, just local Python 3. I'm not actually connected to a Pico at the moment, but it works exactly the same. So what we're going to do, we're going to go and import, let's go down there, import random. And we are going to basically just say a equals random dot random. So we're going to grab a random number like so. So let's just print out A and see what we get. So we get a number there, 0.21 blah blah blah. So if we run that again, let's do B equals random.random and then print out B, get a completely different number. Now let's try something else out. If we do random and then seed, so we're going to seed our random number generator with 100, just going to arbitrarily pick that. And let's do this now. So if we say C equals random.random and we print out what C looks like, we get this number 0.14 and it ends in 303. So what we're going to do, we're going to run that again. We're going to, instead of doing the seed, we're going to set the seed back to 100 again, which effectively starts the algorithm from that same point. And if I now do D equals random, what do we think will happen? Will we get a completely different number, or we get the same number as that 1.4303 at the end? So let's just print out D and see what we get. We get the same number because we've started from the same point. So this is one of the ways that cryptography can work. If you have the same seed number, you can generate the same sequence of random numbers from that same starting point. It's a bit like if you've ever played Minecraft and you have a seed. The seed is the random number generator, and it's the same starting point. So if you have the same seed, you get the same world being generated in Minecraft. So let's have a see if there's anything else. I think that we're good with that. It's the same sequence. Okay, so the other thing I want to look at is if we want to get a random number between two numbers, we have like a minimum and a maximum number, we'll use the range function, the rand range. So let's try that out. So if we say min no, which is our minimum number, equals, let's say 10, and our max no equals 100, we can now say, let's use r equals random dot rand range. Then we can use our minimum number and our maximum number, like so. And if we print out R, we will get a number between those two values. And we can run that again. We can just get another random number. It's still within those ranges. So it'll always be within the minimum and maximum range. Now we can use that if we want to do something like, I want to create a pause in our program, and I want that pause to be between a certain number of seconds. So I want a minimum number of seconds to have elapsed, but no longer than another number. So we can use this rand range function to actually cap and limit our wait that's in there. So it's quite a useful function. So I think that's everything on that one I wanted to cover off. So let me just go back to our slides. Okay, a bit random today's show, isn't it? So we're going to have a look at the 3D design now of the parts that we've created. So I only went through one iteration of this. It's a bit of a dark one, this one. This is the GhostBox lid. So it's made up of a bottom section, a top section, and there's these antennas that fit onto it as well. So these are not 3D printed. These are a little living flame part that you can simply just apply power to, and they'll just do this animation. That's not being driven by the code at all. That's just, you give them 9 volts and they'll start doing that. So I'll show you where we can get those from as well. So the bottom section is really, really simple. I will actually share the dimensions for the Pico and the Pico W because I use them all the time in my 3D printing designs. Like for example, if I'm creating one of these little stands, the measurements for these are always going to be the same. They are something that I use all the time. So it's 51 across, and between the two mounting holes it's 11.4 millimeters. So 51 across, 11.4, and then the actual holes themselves are just 2 millimeters, and they work really, really well. Let me just show you these little, I've got a couple of these. I'll just go over to the overhead for a second. These little bolts I've got here, these are M2 bolts, and they have, if I can grab one, show you the top, they have a little hex nut in the top there. Hex nut, a little hexagonal thing to screw them in with. So I just use these. I didn't drop it. You can basically just use one of these, what do you call it? Hexagonal shaped things to screw in with it. There we go. But yeah, the M2 size, I think these are also about 8 millimeters in length there. I'll probably measure that actually, just to check what that would be. I did drop something. Right, so if I just measure that there, yeah, I think it's basically just 8. let's just put the power on there. I need to get a new one of these. If I just measure the distance between the head and the base there, it's as near as damn it 8. And yeah, these fit perfectly for a lot of the projects I use, and they'll screw into a Pico and you get like a really nice solid join on there. So I've raised it up a little bit. I've also put a little hole in the back there so that if you need to flash your Pico, you need to hold down that button. So that little hole just allows you to sort of stick a pencil through the hole to push that little thing down. You don't have to unscrew the whole thing just to get at that. Cool. So the next one is the top. It's a bit of an elaborate design, this one, and I specifically made it to work around the parts that I had to hand. So these little antenna pieces, like I said, I actually bought these from a company that's called Vern Industries. I'll put a link up in a second on the screen. It came in a little packet, and the idea is that they work with 9 volts. 9 volts is quite a common thing for people who are not really into electronics, but they can get hold of these and they last quite a while, these batteries. But obviously our Pico doesn't work on 9 volts, so we're going to have to do something clever to drop down the 9 volts to 5 volts or 3.3 volts. So we're going to have a look at some of these little buck converter type things to drop it down, little voltage regulator. So the top section is best printed in this orientation. I did try printing this in this orientation with the detail face down, and basically it just didn't work very well. I got a very crunchy surface on there. It doesn't look very nice at all, and that's because it's having to do lots of retraction and you get these little blobs, and it just doesn't do detail very well, is what I found. I also use the text tool and the emboss tool in Fusion 360 to create that nice GhostBox font and little embossed thing there. And I basically just squished down the bit around it, put a nice little circle and some sort of ridges to make it look like a speaker or something like that. Other things I put on this design as well is I put you can't really see this on here, let me just put something behind that so you can see it. There is a hole in here which is for a USB connector, so if you want to plug in to program this while the Pico's in there, you want some kind of hole where you can plug in your USB connector. So there's a little hole for that, and there's also a hole on the top. I really shouldn't have printed this in black, should I? There's a hole on the top there, and this hole is for an on-off switch. So I wanted to get an on-off switch. So I'll show you what they look like on the overhead. So I've got this this on-off switch. Not sure what they are. There you go. XCDI 101. It's a bit heavy duty, but it works quite well. And you can see on the finished version there, I just flick that on. The power starts. That isn't lit up at all, by the way. That's just coloured in with some acrylic, and similar with the GhostBox bit as well. So there we go. And you can see I've just got I've got some stuff from the print bed there, but yeah, you've got the 4 things. I did actually make a mistake when I designed the original version of this, so that's supposed to poke all the way through, but on this version I made a mistake. It doesn't poke all the way through. But no, there are definitely 2.5 size. I mean, you can't really see from that, but they're definitely definitely 2 M2 is what I'm trying to say. So there you go. Got a hole for USB programming. We've got the on-off switch as well. Cool. So the electronics. Let's have a look at these in a bit more detail. So I got these bits and bobs, like I said, from Vern Industries. I got these living flame things, and what he's done is essentially taken a living flame LED and he's put some additional pieces on this to make it a bit more steampunk. So there's like a copper ring at the top, and then looks like some kind of copper pipe connector on the bottom as well, but they look really nice. They'll look very steampunky. So I've got a couple of pieces here just to show you this. I've got the 9-volt battery. We have the 9-volt battery connector with some wires on there. We've got the Pico, obviously, and on this particular project we don't need Wi-Fi. It's just going to run stuff from the Pico, so a regular $4 Pico will work fine. We've got the on-off switch like I showed you, and we've also got these D-Sun step-down switch voltage regulators. Let me show you what they look like. I've got a few of these, so I'll show you what it looks like on the back and on the front. So out goes to that side, it looks like so. So you can see there you've got a couple of inputs and a couple of outputs, and you put the inputs on that side. So 9 volts goes in there and you get 5 volts out. And you've got this little voltage regulator. Just show you that. goodness sake. You've got that little potentiometer just there that you can tweak with a screwdriver, and that'll allow you to change the voltage up and down a little bit. So you want to get that just about right. So I've got mine just under 5 volts, and it's a bit hair raising when you very first plug this into the Pico. And simply all I've done on the Pico is this pin here is the 5 volts in, and if we essentially just solder the output of this 5 volts on the D-Sun into the 5 volts on the Pico will be able to take that and drop it down to 3.3, so it'll work nicely on there. Okay, what else have we got in here? So yeah, I'm just going to give you a bit more detail about this. So I think these can drop down from 23 volts to 5 volts, so they're quite chunky. We're just using 9 volts. You want to ban that first? Thank you. They drop down from 9 volts to 5 volts, which is suitable for powering the Pico. And they can get a little bit warm is one of the things I've noticed, and obviously that's one of the ways it can get rid of the additional voltage, is it just gets rid of it via heat. Now that probably does mean that your battery is basically just making this into a heater, so your battery probably won't last as long, but because I'm using these components that use 9 volts, I've had to use these. So very, very simple to put together. A little potentiometer there to make sure you get that right before you apply that power to the Pico. And I mean, I can't speak to how good these regulators are, but I've not had any problems just yet. I'd be worried about that, about a spike when you very first turn this on. It might basically just blow the Pico up, but I haven't found that that actually happens. So yeah, Verne Industries. I met this guy in Whitby, I think it was back in February when I bought these parts. There was a steampunk festival and I went along to that and picked up a few bits and bobs, including this amazing Kraken Detector, which he created. I absolutely love this. I love the style of it. It's all laser cut pieces with finished with some nice LEDs and a nice big chunky on-off button there as well. And again, this runs just on a 9 volt battery, which is just in the bottom there. So that's where I got these Living Flame LED lights from. I think they're actually sold out at the moment on the store, but maybe if we pester him enough, he'll make up some more. So it looks like you can see on the screen there, we've got these other LEDs. These are the ones I can find on like Amazon or Google, and they look exactly the same apart from there's this brass attachment and the brass ring at the top, and essentially I think that's what he's done. He's just added that to it and put some cable on there. So yeah, really, really cool, really nice little steampunky vibe, and just makes our ghost detector look a bit more interesting. Doesn't actually do anything, and this is rare for me. Normally when I make things, they're very functional, they do what they're supposed to do. This is more of an art piece, I would say, because it doesn't actually do anything, just looks cool. Maybe it attracts the spirits in. So let's have a look at some Micropython code as well. So one of the things I wanted to do on this is I've got a little screen and I want to center the text that's going to play on that screen. And the formula for doing this is pretty straightforward, but it's one of those like you just need to get your head around it first. So I've got this, I'm using Pico graphics to display the JPEG on the screen. I've created a JPEG just using canva.com. And what I want to then do is use Pico graphics to display the text using the Gothic font. And I want to center that text on the screen. So this is our little screen here. This is the text, and I want that to be exactly in the middle. So how do we do that? So there is a nice handy function in Pico graphics that's called measure text. A measure text will give us the exact length of the string in pixels in that specific font that we provided, with the correct spacing and so on. So we can take that length and then we can say, okay, let's halve that length. So the length divided by 2. And really you want to use the slash rather than the slash, so you'll get a floating point number. And we also want to get the length of the screen, the width of the screen, and we want to halve that as well. And then what we want to do to get our X value, so we want to basically find what this position here is. And it's the width of the screen divided by 2 minus the length of the text string divided by 2. And that will give us that starting point there and center our text nicely. So nice little formula. X equals width divided by 2 minus length divided by 2. Okay, so if you like what I do and you want me to carry on making these shows like I am doing, then please give this video a like. Drop me a comment. Let me know if you believe in ghosts. That's something I'm very interested to know about. And make sure you subscribe to the channel. Hit that little bell button. I think about 75% of people who watch this don't subscribe yet. So help me out. If everybody's subscribed, I would have over 500,000 subscribers by now. So we need to increase that number, I think. And I go live every single Sunday, 7 o'clock-ish GMT. So I think at the end of this month, we will be back into GMT, because we're currently in GMT +1, Daylight Savings, British Summertime.
Not got one next week.
Yes, and we don't have a show next week. Thank you, Alex, for reminding me of that. So having a little break, and we'll be back the week after. So, reading files. We're going to be reading some files in this project. Well, one file, which is our words file. So we're going to define a variable that's called ghost words. And in that file, it's just going to be a plain text file. And each line is going to have a separate word on it. And we can put as many words as we like in this within reason. Within reason just means if we put too many in, we might run out of RAM on our Pico. But I think you can put quite a few in there without worrying about that. So we're going to read this in as a read-only file. So that's what this R means here. We're going to read in whatever that file name is that's stored in the variable ghost words. And this with open means basically go through, it's like a for loop. It'll read every single line in, and it will return it as F. So F will be the contents of that file. And we can split the words that are read in there and return that list of words by using this return f.read.splitlines. So split lines will actually split it up into a nice list for us. So what we get back then is a list with all the different words that are in there. And we can then use the choose function to choose a random word. So we'll have a play with that as well. Okay, so let's have a demo of that too. So let me get back to, let's go back to me for a second, and let's load up Thonny. And let's have a look at some of this code, shall we? So what I've said on here as well is note that this project uses the batteries included MicroPython firmware from Pimoroni. You can grab this from github.com/Pimoroni/Pimoroni-Pico. We'll have a look at that in a second, because that's also got some details about how that Pico graphics module works. And that's something that's quite useful. So let me just go and grab that on screen now. Let's go to github/Pimoroni-Pico. There we go. What's all this about? Just confirm that's fine. Right, so I'm here on the Pimoroni Pico, and if we scroll down here, we can see there's some tutorials and text, and there's also this README for the Pico graphics. I'm just going to jump to that so we get to the correct page. And we can see on here is all the functional reference for all the bits and pieces we need. So for example, drawing text on screen, we can see how to set a font. We're going to be using the Gothic font. So we just need to do display.setFont with Gothic in some speech marks, and that'll work fine. And then to draw text, we need to do display.text. So we need the actual text to write on the screen. We need the X and the Y coordinate on the screen where we want to write it. We can choose a word wrap, and that's the how many pixels do you want to wide before you break that into an additional line and write it underneath. Scale will scale the font up, so you can make it like twice the size or just 1 time size. And if it's one of these vector fonts, one of these here, not the bitmap ones, you can actually draw them on an angle, which is quite cool. That's me just defining what an angle is. And then spacing is how many pixels between each character do we want to be on there. So just like it says here. So that's a quite nice reference how to display text on a screen. And we've got that measure function as well. We put in the text, we put in the scale, and we put in the spacing as well. And then what it'll bring back is how many pixels wide that's going to be. And we can then use that on our little algorithm to center the text on the screen. So I just wanted to show you that. Let's head on back to Thonny. So yes, I'm using the firmware that's got Pico graphics built in. If you try and run regular MicroPython or CircuitPython, this won't work because it uses this Pico graphics library. And that's because I'm using the Pimoroni display pack, which is this little board, and it has the Pico just plugs into the back. So you've probably seen these before on quite a few projects. When I did the Pomodoro robots, that had one, and you can see there. And what I like about these is it means you can mount the Pico just using the regular Pico mounting points, plug this in, and you've got a really nice project. Nice and simple. Okay, so we're going to use random. We've played with random just a minute ago. We're going to use our rand range, and we're also going to use this choice function as well. So choice we can use to choose from a list. So let's just go down here for a second. Let's just define, let's say fruit, and let's just define some fruit. So let's have apple, let's have pear, let's have orange, and let's have blueberry, like so. And if we say from random import choice, we Why is it not found choice? Random I've typed with an E on the end. Obviously that's not correct. Let me just grab that. Let me get rid of that helpful assistant there, and let me just type that in again without the E, and let's try that again. Okay, so if I now say my choice equals, and then choice, and then we just pass in fruit. And what it will do is it'll randomly choose one of those fruits and put it into my choice. So if I just type my choice, we've got blueberry that time. If we do that again, and we type that out, we get orange that time. We do that again, blueberry again, and so on. So let's try, and they get apple that time. So choice is a way of just picking something from a list and then presenting that to us as that variable. So that's what we're going to use. We're going to use that and run range. We're going to bring in time and sleep because we want to sleep for a certain amount of seconds. Otherwise, it'll just be displaying words as fast as it can. We don't want that. We want it to sort of pause for a second. I don't think we're using bin ASCII on this particular project, so we can probably get rid of that actually, but we are using Pico graphics and the display pack 2. So depending which size of display you have, and there's a number that are compatible with Pico graphics. Again, if you go back to that Pico graphics website, you can find out which Pimoroni displays are supported, and it does include the what was it called? The Explorer. I've not got it to hand, but I use that for all kinds of like testing purposes. Is that it? Yeah, there we go. That's what I was trying to find. I absolutely love these Pico Explorers. So this Pico Explorer is a little board. You put your Pico into there and you've got a nice big display here to test stuff out on. That display is also compatible with this too. Dale's asking, do I have an Instagram? I do have an Instagram, Dale. You can grab that from here. So yeah, Kevin McAleer, Instagram. Anyway, let's carry on. Let's carry on with the show. So what else have we got on here? JPEG. So JPEG decode will allow us to read in a JPEG file. We can't read in like a massive size JPEG. Remember, the Pico's only got 254K of RAM. 264K of RAM, so the Pico can be nowhere near as large as that. So you want to squash it down. And obviously, if this display is like 320 by 240, we only want a JPEG that's that size, just so we're not using up too much RAM. So a couple of K is fine for a JPEG. We're going to bring in the Pimoroni RGB LED and the buttons. That's just in case we want to use the RGB LED, which is built onto the display, and these buttons as well. So I actually don't use these, but I could create a little menu system if I wanted to take this project a bit further. We're also going to bring in the garbage collector. Because we're doing things with images and displaying text and so on, it does use up quite a lot of RAM, and we want nice contiguous pieces of RAM. So if we do garbage collection, that will help just make that work. So GC collect is just background cleaning up of memory. We're going to use math and machine, I think. Not sure if we actually use them on this project. And then the most important thing we do is we set up this variable that's called display. We use the Pico graphics library to set that display up, and we're going to set the rotation to 0. So you can have different orientations of screen, like 0, 90 degrees, 270, 180. We don't need any rotation on this. This is fine. We're kind of using it as it's intended. And then we can grab the width and the height of this particular display. And this makes our code a little bit more portable. So if I was testing this code out, for example, on this Pico Explorer, by using that get bounds, I'll get the width of this particular display rather than setting this arbitrarily in the code. I then set the scale to 1 and the spacing to 1. So the scale is just the text scaling. The width, the spacing is the space between each character, so 1 pixel is fine for that. And the word wrap, we can basically just say if we want to make sure that text doesn't scroll off the end of the screen, so any text that's larger than the screen, basically wrap that round. So what I've said there is word wrap equals whatever the width of the screen is, just -2 arbitrarily. And then we've set up some of the buttons just in case we want to use these for a future piece. And similar with the LED, the RGB LED, that's the onboard RGB LED, which sits just in between the buttons A and B. I then just print out, just to help debug, to the screen, the width and the height of the screen, just so we can see what they are. And then I set up 2 colours. So I'm going to set up white and black. So white is 255, 255, 255 for the R, G and B values, and black is obviously 000. And we use this when we use the set pen function. And this is quite common with graphics libraries. You set a pen color, and then any drawing functions you do use that current pen color. So you just need to remember what kind of color you want to use. And if you want to clear the display, you either set it to white or black before you do the clear function, and then it'll clear to whatever color, white or black you've decided there. We've then got a little function for drawing JPEGs. So we're going to use the JPEG decoding JPEG display. So the display is just the graphics driver that we're currently using. We're going to pass it in a file name of the JPEG that we want to display. And obviously that needs to be uploaded onto our Pico beforehand. And then we do open file, the file name. We've already got the width and height. This is a little bit redundant. We could probably get rid of that line there. But then we do display set clip. Clip is like a way of reducing the amount of pixels that are going to be written to on the screen. And it means we can protect those pixels if we don't want to overwrite them. So it's a way of just like discreetly, carefully writing to an area of screen. Now we're just doing 0, 0 to the width and the height. So we're just using the full width of the screen, but it's quite a good practice to do set clip and then remove clip after you've finished it. And then to actually display it on the screen, we do J, which is our file name, our JPEG file name, dot decode, 0, 0 is the X and the Y. The JPEG full scale means it's going to draw it at the full size that the JPEG is. So if our JPEG was larger than our screen, we would see kind of like a zoomed in version that would just be the 1 pixel per 1 pixel on the screen. And then display to update, we need to make sure we call that after every graphics operation we do, and that will actually make it appear on the screen. We don't want to call display to update too frequently, otherwise the screen will flicker. So we want to make sure we do this after we're confident that nothing else needs to be written to the screen. So sometimes I move that just to the main loop and don't have them in sub-functions like this. Okay, nearly done now. It's quite a short program, this. So then ghost words is just the name of our text file. So let's just load up ghost words and have a look what that looks like. So I've just put some spooky words in here. We can add as many of those as we like. And they're the words that are going to appear on the screen. So I've just arbitrarily picked a couple of them. The haunted clock thing there is clearly playing on my mind. And then GhostBox is the little graphic that will display on the screen, and it's kind of like a Ouija board, that kind of feel, but actually not. And then the minimum wait and maximum wait is how many seconds we want to wait between displaying a new word on the screen. So it's going to basically show something for a random number between 1 and 10, and we can make that be whatever we want. It's quite useful when you're debugging your code to make that wait time shorter, so you're not waiting too long, but in practice 1 to 10 seconds seems to be quite a good time. So the next one, this load ghost words, we've just saw that example before on our slides. This is going to take our ghost words file, it's going to read that in, it's going to split them up into a list, and we can then use our list a bit like we did with our fruit down there to get a random word that we're going to display on the screen. So we basically say words equals load ghost words, which is this piece here. So words will now contain a list of all our words. We then do a white pen and a black pen, and we use our display driver to create a pen. We have to pass in the R, G and B values. Could probably do a little function to do this so that we don't have to spell it out each time. And then we set the display font to be Gothic, just to make it look spooky and kind of Victorian-esque, which is a lot of spooky things seem to be stuck in that kind of time era, when spirituality was kind of, it's not spirituality, what the spiritualism was reaching its sort of peak. And then we have the main loop of our program. So wait is going to be rand range, min wait, and max wait. So we're going to wait between 1 and 10 seconds. We're going to sleep for that amount of time. And then we're going to set our display pen to black, clear the screen, draw our nice spooky Ouija board thing to the display. We then do an update so that the JPEG appears on the screen. Then we're going to pick a random word from that words list. So word equals choice words. We print that to the screen just to show you what that actually looks like. We then set the pen to white because we want to make the word appear white on the screen. And we use that little algorithm, and I've done it kind of the long way, rather than just doing it in like a single line. So I've said the length equals the measure the text, so whatever the word scale and spacing provides. So we'll get the exact number of pixels for that. We then find the midpoint between in the display. So if the display is 320, we will get what's that, 160? Is that right? And then we use these double slashes, means we get an integer back rather than like a floating point number. And then we say x equals the midpoint, which we've got there, minus the length, which we've got there, divided by 2. And again, we use the double slash to get the floating point number. And what I mean by the integer number, so for example, if I just say, let's say a equals 3 and b equals 7, and then we say c equals a divided by b. Let's print out c. We get like a floating point number. Now, if we didn't want to do that, if we said slash slash, and then we print out what c is, we get the rounded up version of that. So let's try b divided by a. Probably a bad example, this, because it's always going to be a small number, but there you go. So if I just do the singular one, I get the floating point number. So let's print out there. You got 2.333 reoccurring. So double slashes just means you get a nice integer back, which is a lot easier to work with, particularly when it's pixels on a screen. You don't have like half a pixel. And there we go. So that's the x position. We then just print some details to the screen. Again, this was useful for debugging stuff. So what was the length of the screen? What was the midpoint? And what's the x position? That should always be like a positive number between 0 and the length of the screen. And then the y position, I found that the best place for this to be on the screen was like 100 pixels down. And it's 320 by 240, so it's about the middle of the screen. And then I do display the word that we've chosen from our choice of words. The x and y, the x we've divided by making sure it's in the middle of the screen. The y position is our 100. Word wrap is whatever we've set that to be, which was the size of the screen, and the scale I think we set to 1. And then we update the screen. So let's have a play with this. I'm going to go to the overhead screen. I'm going to switch this on, and it'll wait a random number of seconds between 1 and 10. And then you can see there, it says hand, and it's going to choose another word in a second. So you would ask the spirits to choose another word. Clock. See, it's the haunted clock. It's mentioning this again. Spaghetti. Let's see what happens next. And again, it's just waiting a second between 1 and 10. Help. Well, that's spooky. It said help again. So it really, really does want help. I think there's a spirit trapped in the clock. Is there a spirit trapped in the clock? Let's see what it says. Hand. The hands of the clock, maybe. Maybe there's a spirit on the hands of the clock. Oh, on the leg. So you can see this is not connected to anything. It's not got a Wi-Fi device in it. It's just choosing from those random lists. So there you go. You can see there the little graphic we've got on there. It says GhostBox, mystifying oracle, yes, no. And it's got 2 little hands, and there's some just like little ornate bits on there as well. And you can see that white text there, I just went over with some acrylic paint on that, and I painted that little button there as well. So you can see there we've got, it was a bit of a squeeze to get all the electronics in, hence you can see some of the wires that are sticking through there, and you can also see just some debris from the print bed. I think I need to get a new print bed, and there's those M2 screws holding sort of everything in place. And yeah, you can see these things. If I turn out the overhead light, we can get more of a flickery look at that. So these living flames ones look quite nice, look quite spooky. And our GhostBox, it doesn't make any noises at the moment, so I think that's the next upgrade to make to this. And if I just flick it off it goes. And yeah, that's our GhostBox. Let me just come back over to me for a second. So yeah, one of the things I was thinking about, I've got these this Pico audio pack, which I mean, unfortunately, you can only plug one pack in at a time, but you can get these pack extenders from Pimoroni that you can have several packs plugged into one Pico. And this uses I2S, which is like an audio standard for Picos, and it's got a line out. It's got a high gain and low gain button there as well, and it's got like a headphone or a line out. So we'd have to plug that into something that would then have some speakers or something that we can actually hear what's being played back. So I'm very interested to know how we can get more audio working with Micropython. So that's one of the things I want to investigate. I was talking to Matt about that earlier. Okay, so let's go back over to our slides. see what else we've got on here. So yes, if you haven't joined our Discord server yet, you're definitely missing out. We've got quite a lot going on in there. People talking about some of the project builds that they're currently working on. There's been some really quite cool projects in there as well. Very impressed with what people are working on. So yeah, head over to kevsrobots.com/discord if you want to join that. I'm going to take the conversation further. And as Dale was asking, am I on Instagram? Yes, I'm on Instagram, and I'm also on Twitter as well. So there's my Instagram handle at Kevin McAleer and at KevsMac on Twitter. And on YouTube, it's just at Kevin McAleer 28. That's my handle, which YouTube have just launched. You'll probably see a bit more of that. You'll probably also see that I've been doing quite a few shorts this week. I've been doing some experiments on YouTube to see what kind of videos work for discovery. So if you want to help out the show, you can do that in a couple of different ways. You can do a super thanks. So if you're watching this on replay, you can press the super thanks button, and I'll get that message through and that little donation through as well, which really, really helps. And the super chat is if you're watching this live now and you want to do a super chat. Let me just make sure I've got all the super chat stuff switched on here. Yeah, we're all good on that. And there's also the buy me a coffee thing, which I've just switched on in the corner as well. So you can go to kesrobot.com/coffee if you want to buy me a coffee. We had quite a few people do this week, so I'm really, really happy and pleased about that. It really just helps pay for all the number of things I have to buy from the companies to do all these cool projects. And obviously you can join the YouTube membership as well. We've got a couple of people who joined that, and again, that really just helps support the show. Okay, so let me just go to the next one. And yes, our supporters. So we have a couple of supporters I want to sort of call out. So you can see there we've got Matt Hungerford, we've got Flavia of Dev, we have Patrick, we have Robert, Matt, another Matt, we have Stephen, and we have Tekri. And then the members, the people who've joined the Buy Me a Coffee membership, we've got Stephen, Chemi, and Thomas. And YouTube members, we've got 5 YouTube members currently. So we've got Jose, we have Jeff, we have Joan, we have John Paul, and we have Tom as well. Tom's one of our longest supporters. So thank you guys for contributing and helping me keep the channel running a couple of weeks longer. So thank you very much indeed for that. Okay, let's have a see if there's anything else. No, I think that's it. We're all good. So yeah, tell me if you believe in ghosts or not. Is that something? Have you actually got a real ghost spirit box thing? I'd be quite interested to know who's got one of these. And yeah, let me know if this is something you'd be interested in building too. You might have some trouble getting hold of these components because at the moment they're out of stock at Vern Industries, but you might be able to make your own using one of these little brass pieces and a brass ring on some regular ones too. But I'll put the files up so you can download them as well as the code. I'll put the link to that in the show notes as well. Cool. So this is the point in the video where if you're watching on replay, I'll say thank you so much for watching, and I shall see you next time.